Hello everyone, my name is Pranjal Jain. Today we are going to solve a very interesting question. It's called set matrix zeros. First of all, we'll understand the question. Then we'll move towards a brute force solution. And finally, we'll work our way towards an optimal solution. Make sure to watch the entire video to understand the whole thing. So let's get started. So the question is, given an M cross N matrix, if an element is zero, set its entire row and column to zeros. That's it. That's the question. You must do it in place. What do you mean by in place? It's very simple. The matrix that has been given to you as input, you have to change that matrix and return it as the output as well. Okay. You don't have to make a new matrix and return that as the output. You have to make the changes in the given matrix itself. That is all that is meant by in place. So let's try to understand what the question is with one very small example. Let's take this example 2 that they have given, 0, 1, 2, 0. 3, 4, 5, 2. 1, 3, 1, 5. So let me just highlight the zeros that are there in the matrix. This is one of them. And this is the second zero. There are no other zeros in the matrix. Let me give the row and column numbers. So this is row 0, row 1, row 2, column 0, column 1, column 2, column 3. Now, in whichever row or column there is a zero, we make the entire row or column a zero. That's it. That's the question. So in row 0, there is a zero. So we will make all the elements as zeros. In row 1, there is no zero. All right, we can keep it as it is for now. In row 2, there is no zero. We can keep it as it is. Now, let's handle the columns. In column 0, there is a zero. So we'll make the entire column 0 zeros. In column 1, there is no zero. So we won't change anything in this. In column 2, there is no zero. We won't change anything in this. In column 3, there is again a zero. So we will make column 3 all zeros. So this is what the output should be. That's it. This is the entire question. I hope the question is quite clear by now. So let us move on to its solution. First of all, there is one solution that comes to a lot of students' mind. So let me just explain that solution to you, and we'll also look whether it is correct or not. Okay, the simplest solution that can come to your mind is, let me just show you with the same example. So it was 0, 1, 2, 0, 3, 4, 5, 2, 1, 3, 1, 5. Okay. Now the simplest solution that can come to your mind is, we can iterate the array. We can iterate this matrix. Whenever we hit a zero, we make the entire row and column as zero and we move forward. Okay. Let us see whether it works or not. So we start our iteration from here. We hit a zero. Let us make the row and column zero. All right. So we have made the rows and columns zeros. Now we move forward. The problem is we don't know whether this is an original zero that was originally in the array or something that we have added. If we don't know the distinction and still we make the rows and columns zeros, what will happen is column number 1, column with index 1 will also become zeros. But this we did not have to do because this is not an original zero. This is something that we have added. And that is why we'll reach an incorrect solution to this particular problem if we use this solution. So it doesn't work. All right. I hope that much is clear to all of you. With that said, let us move on to the brute force solution. Okay. what we will do is, it's very simple. We will make we will make two extra arrays, one to represent the columns, the other to represent the rows. Look at it very carefully. It's very easy. Okay, don't worry. 0, 1, 2, 0, 3, 4, 5, 2, and 1, 3, 1, 5. Okay. So we will make an array that will tell us which columns have zeros, and we will make a array that will tell us which rows have zeros in it. Initially, they will all be initialized to ones. Okay. The size of this column array or C array would be equal to the number of columns this matrix has, and the size of the row array or the R array will be equal to the number of rows this particular matrix has. Now we iterate this particular matrix, the input matrix. So we have hit a 0. So we make the corresponding elements in column and row arrays as zeros. So we make these zeros. Okay. We don't make any other changes right now. We simply move forward to the next element. This is not a 0. Nothing has to be done. Not a 0. Nothing has to be done. This is again a 0. So we make the corresponding elements 0. In the row array, it is already a 0. Nothing to change. Keep moving forward. Not a 0. 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 And not a 0. And we are done with the iteration part. We have iterated the entire matrix. Whichever elements are zeros, corresponding to that, we have made the column and the rows zeros. Now we start updating the whole matrix to the final answer. How do we do that? We go to any element, we again iterate the whole thing. Its column number is 0 and row number is 0. So what we are basically trying to do over here is matrix of ij will now be equal to matrix of I j multiplied by column of j multiplied by row of I. So what will happen here is whenever there is a 0 in either the row or the column or in both, that number becomes a 0. Look at it very carefully. Now 0 multiplied by 0 multiplied by 0 is a 0. We move forward. Now 1 multiplied by 1 multiplied by 0. Again, it becomes a 0. Why? Because the 0th row had a original 0 in it. So the entire 0th row has to become a 0. Okay. So this will become a 0. Then we'll move forward. Same thing happens 2 into 1 into 0. Again, it is a 0. So it converts to 0. The next number is already 0. So it stays a 0. This one, 3. Does it become a 0 or not? Look at this very carefully. 3 multiplied by 1 multiplied by 0. It is a 0. Why? Because column 0 had an original 0. Here it is. So yes, this becomes a 0. Now look at the next number. 4 multiplied by 1 multiplied by 1. This doesn't become a 0. Because neither column 1 nor row 1 had an original 0 in it. So it stays as it is. We move forward. 5 multiplied by 1 multiplied by 1. It stays as it is. 2 multiplied by 0 multiplied by 1. 2 becomes a 0. Because this column had a original 0 in it. This one, right? Okay. And we keep moving forward. We keep applying the same formula. 1 multiplied by 0 multiplied by 1 is a 0. 3 multiplied by 1 multiplied by 1, 3 stays the same. 1 multiplied by 1 multiplied by 1, 1 stays the same. And 5 multiplied by 0 multiplied by 1, 5 becomes a 0. And finally, when this is done, we have our final answer on the side. 0, 0, 0, 0, 0, 0, 0, 0, and 4, 5, 3, 1. All right. I hope this approach is also clear to you. This approach will take, in terms of time complexity, O of n cross m time, because we are iterating the entire array. But in terms of space complexity, it will take O of maximum of n comma m. Or you can also write it as, if you want to write it simply, O of n plus m. Because we are taking two arrays. One is the size m, that is number of columns. The other is n, that is number of rows. So this is the approach that works. This is what you call the brute force approach for this particular question. We can optimize this further. I hope this is clear to all of you, but there is further optimization that can be done. And by the time we are done with the optimization, the time complexity will become O of m cross n, and space complexity will become O of 1. I'll just show you how this method works. But before that, what you need to understand is, if after giving this solution, the interviewer tells you that you have to optimize it, so you have to realize that without traversing the array, you or the matrix, you wouldn't know where the zeros are. So the time complexity cannot go below O of m cross n. There is only space complexity that you can work on. Okay? We have to take such hints. All right. So this is what our aim is. Let's see how we can achieve this. So again, we'll take the same example, 0, 1 to 0. 3, 4, 5, 2. 1, 3, 1, 5. Okay? Now, instead of arrays, we'll just take two variables. There is a C variable, which tells us, listen to this very carefully. Is there a 0 in the 0th column? We traverse the 0th column and we check whether there is a 0 or not. Yes, there is a 0. So we mark it as a 0. Otherwise, we would mark it as a 1. That's it. Then we take a variable R. What does it tell us? Is there a 0 in the 0th row? I'll just write it down. Is there a 0 in the 0th column? And this one is going to tell us, is there a 0 in the 0th row? Okay. So we traverse the 0th row and we find out whether there is a 0 or not. And yes, there is a 0. So we mark it as a 0. When the 0 exists, you mark these variables as zeros. When there is no 0, you mark it as 1. As simple as that. Now, what to do next? Now, this is very interesting, guys. This is very interesting. You have to consider this as the C array that we took and this as the R array that we took. Now, this is what we are going to consider these two, this row and column as. Now, let me tell you how we are going to run this. Now, to explain this better, I'll just change one number. Let's make it 0, okay? We've changed the original input. We have added a 0 over there. Now, what we will do is we will traverse the remaining matrix from here. Is this a 0? No, it is not. Is this a 0? Yes, it is. So we mark the corresponding element in C array and R arrays as zeros. Okay, we move forward. Is this a 0? No. Is this a 0? No. Is this a 0? Again, no. And is this a 0? Again, no. All right. Now, this is the matrix that we have. I'll just redraw this clearly. 0, 1, 0, 0, 0, 1, 4, 0, 2, 3, 1, 5. Now, what do we do next? Because we are treating these as R arrays and C arrays. We do the same thing once again. We come to 4. Now we check. In the R array, it's a 0. In the C array, it's a 1. So that means that there is an original 0 in row number 1. That is over here. All right. So we make this 4 as a 0. This is already a 0. This 2. Should we convert it to 0 or not? Let's check the corresponding numbers in the C array and R array. This is a 0. This is a 0. So 2 into 0, again, it's a 0. We come over here. 3. 3 into 1, it's a 3. So we don't change that. You get this one. 1 into 1, it's a 0. We convert it to 0. Then we come over here. 5 into 1, it's a 0. So we convert it to 0. So the output so far looks something like this. 0, 1, 0, 0, 0, 1, 0, 0, 0, 3, 0, 0. We have these two variables, C and R. We will multiply the entire first column with the C variable and the entire first row with the R variable. So C variable is 0, 0 into 0 is 0, 0 into 0 is 0, 1 into 0 is 0. R is 0, so 0 into 0 is 0, 1 into 0 is 0, all the other numbers are already 0. So this is what the outcome has come out to be. Let me tell you what the input was. This is what we modified the input to be. 0, 1, 2, 0, 3, 4, 0, 2, 1, 3, 1, 5. And we converted it to a output of all zeros, just the 3 is there. 0, 0, 0, 0, 0, 0, 0, 0, 0, 3, 0, 0. Now you can confirm that we are actually getting the right answer, the answer that we actually want out of this particular matrix that is given to us. The time complexity for this again is O of m cross n, and the space complexity we have reduced to O of 1 because we are not using any extra array, we are just using two variables. So yes, we have achieved our goal of using O of m cross n time complexity and O of 1 space complexity. Now moving on to the code. Now we are going to code the optimal solution for the problem. So we took two variables for this. There was a C and there was a R. We are going to initialize both of them with 1. Right? When we find the zeros in the corresponding column or row, we are going to make them zeros. Now we are going to iterate the 0th column of this matrix. Int I equal to 0, I less than matrix dot size I plus plus. If we find an element that is matrix of I comma j is equal to 0, the column number is going to be 0 throughout. We are going to make C equal to 0. Okay. Similarly, we are going to traverse the 0th row now. So int I equal to 0, I less than matrix of 0 dot size and I plus plus. If we find any element that is matrix of 0i equal to 0, we will make R equal to 0 this time. Now, as we discussed in the solution, we are going to traverse the remaining matrix, and we are going to mark the corresponding elements as zeros. Okay, so let's do that. So for int I equal to 1, I less than matrix dot size, I plus plus. Then for int j equal to 1, we are starting I and j from 1s because we have reserved the 0th row and the 0th column for C array and R array, right? J less than matrix of 0 dot size and j plus plus. Now we will check if matrix of ij, if this current element that we are on, if it's a 0, we make the corresponding values 0 in the first row and the first column. So matrix of 0j and I0 will become 0. Okay. Once we have done that, we will again traverse the entire matrix. So for int I equal to 1, I less than matrix dot size and I plus plus for int j equal to 1, j less than matrix of 0 dot size j plus plus. Inside this, we will simply check if matrix of 0 j is equal to 0 or matrix of I0 is equal to 0. Then we will make the current element 0. And that's pretty much it. Now for the remainder matrix, we have made the elements 0. Now coming to the first row in the first column, as discussed earlier, we will simply check if the value of C is equal to 0. We will make the entire first column equal to 0. So let's do that. Matrix of I 0 equal to 0. And similarly, if R is equal to 0, we will make the first entire row equal to 0. So for int I equal to 0, I less than matrix of 0 dot size I plus plus, we will make matrix of 0i equal to 0. And that's it. Let's try to run this. Now let's try to submit this solution. So here we can see we are able to solve all the test cases that have been given to us. Thank you so much for watching the video. Whatever doubts you have, feel free to put them in the comments and I'll be more than happy to answer all of your doubts. And if you haven't subscribed to us yet, please do for more interesting questions just like this. Thank you so much, guys. Have a great day.